Hi everyone, in this second kinematics video we're going to be looking at this example just to illustrate further the concepts that we learned in that first kinematics video. So a rock is thrown vertically upwards with an initial velocity of 40 meters per second. So it's handy just to highlight some of the key information you find. So from a point 5 meters above the ground level, the velocity after the rock after t seconds is given by the formula v equals that. So it's just worthwhile noting that that's velocity, and so velocity is sort of sits between distance and acceleration, and so to get to acceleration we differentiate, and then to get to distance we'd have to anti-differentiate. Okay, so find an expression for the height of the rock above the ground level at time t. So that is talking about the distance, and so that means that we have to anti-differentiate, and so that's going to be s, which will be equal to the antiderivative of 40 minus 10t dt. So that will be 40t minus 5t squared plus c, and we know that when t is 0 that it's 5 meters above, and so we could say that 5 equals c, and so our distance s is going to be 40t minus 5t squared plus 5. Okay, question B, find the maximum height reached by the rock. So maximum height will occur when the velocity is 0, because if you can imagine, the rock will go up and its velocity will decrease until it reaches a pinnacle, and then it comes down again, and at that point the gradient is 0. So that means that we need to differentiate. Well, we just have to set the velocity equal to 0. So we'll go B, and we'll make velocity equal to 0, 40 minus 10t, and solve that for t. So 10t equals 40, so t equals 4. Okay, but it's asking for the maximum height, so we need to substitute that number 4 in for t into distance. So we're looking at the distance when t is equal to 4, so we'd have 40 times 4 minus 5 times 4 squared plus 5. So it's 160 minus 80, so that's 80 plus 5, so 85 meters is the maximum height. Okay, calculate the distance travelled in the third second. So for this we would have to work out the distance at 3 seconds. So that would be 40 times 3 minus 5 times 3 squared plus 5. So that's going to be 120 minus 45. So that's 75 plus 5 is 80. And then we'll look at the distance at 4 seconds. And that's going to be, well, we've just worked it out, 85. And so it travels 5 meters in the third second. So 5 meters travelled in the third second. Okay, question 2. So for this last problem, when does the rock return to the ground, we're going to set distance equal to 0. So I'll write out 0 equals 40t minus 5t squared plus 5, and we'll solve that equation for t, because when distance is 0 that means that it will be at ground level. Okay, so we'll rearrange it to make the t squared term positive. So then we'll have minus 40t minus 5 equals 0, and we'll divide through by 5, so t squared minus 8t minus 1 equals 0. Okay, now we'll get our calculator out to solve that quadratic, and we'll make that size better. There we go. And we will have, we'll go into equation mode, and I've already got it in there, but I'll change that coefficient to -1. There we go. And there's our two possible times. T equals 8.123, or t equals, and the other time was -0.123. And if we think about the context of the question, this answer makes sense, and this answer does not make sense because that's backwards in time. And so t equals 8.123 is our answer for when the rock returns to the ground. Okay, people, I'll get you to have a go at these exercises to practice similar problems like this, but hopefully you're starting to see the link between distance, velocity, and acceleration, and how you get from one to the other using differentiation or anti-differentiation. Thank you.